Hi, I'm an old guy and I do maths. And today we're going to look at how you graph something that is unfamiliar to you, an unfamiliar function. And the one I've chosen is an example that a student of mine was given as a part of a class challenge. And it is y equals x minus 2 to the power of 1/3. A fractional index, power here, root here, so we're looking at the third root of this expression. So, what does one do? Well, I wouldn't go trying to expand this thing. I don't think it'd be pleasant, and I think it would be counterproductive. There are two things that we can do really, really quickly. We can put 0 into this thing, make x equal 0 and see what happens. Well, if we do that, this becomes -2, and the third root of -2 is 1 point something. So we'll just put a dot there and say that that is 0 third root of -2. That's very badly written, but that point is 0 third root of -2. Now, the next thing to do is to make this equal 0 and see what happens. So in order to make this equal 0, x must equal 2. So we have a point here, 2, 0. And look, we've got 2 points of intersection, one on the x-axis, one on the y-axis already. We don't know what else there is, but the next thing to do is we're looking for third roots. And so let's look for the third root of a number that's really, really easy. So how about the third root of 1? So we'll make this bracket equal 1, in which case x has to equal 3. So if we put a point here on the x-axis, that means that x equals 3, so this bracket equals 1. The third root of 1 is 1. So this point here is 3, 1. Now let's see if that corresponds to something here. Let's see if this thing's symmetrical. I have a suspicion it is. So how do we make this bracket equal what? -1? Well, we make this equal 1. 1 minus 2 is -1. So 1 is there, let's say, and the third root of -1 is -1. So we've got a point here which is 1, -1. This is all very encouraging. Now, let's see if we can get something along here in this region and something here. Okay, so what else do we know the third root of? We've tried 1. Third root of 8. That's a whole number. It's 2. So how do we make this equal 8? Well, we make x equal 10. So out here somewhere maybe this point we'll say is 10. So 10 minus 2 is 8. The third root of 8 is 2. So this point here is 10, 2. Join up these dots and see what's going on. We can get a clue as to where we're headed. Okay, I think that's a pretty good clue. So let's try something over here. Now, we can find the third root of -8. The third root of -8 is -2. How do we make this equal -8? Well, we make x equal 6. -6 minus 2, -8. Third root thereof is 2. So we'll say that this point here is -6, and this will be -2. And some more left-handed artwork, and away we go. I think we've got a pretty fair impression of what this function looks like when it's graphed. And what I would like you to to take from this is the process. Start out by making this equal 0. See what happens when you put 0 into this. And as you're looking for third roots, find numbers where the third root is a whole number, and you can set about graphing this thing. So what this turns out to be is something that probably started off as a familiar function, and somebody decided that it would be fun to find its inverse. So it's a reflection of a cubic. All very interesting. Thanks very much for watching. See you next time.